as well. And I think with that, we have our team from Aquifer Beach with us today. That's our consultants that are working on this project. And I think I will pass it over to Dave Maunder, who's the project manager, to introduce the project.
Thanks, Ian. And I'll introduce the study team in a couple of minutes, so we'll introduce it. So the agenda today, as Ian said, is just to introduce the project team. Ian will give a land acknowledgement. We'll go through the study purpose. As you'll see in a moment, this is presenting the phase 1 results. And in layperson's terms, what we've done is we've spent the time to date to look at and sort of define what existing conditions are. So the existing conditions from a natural habitat perspective, from a flooding perspective, from an erosion perspective, from practical things that people may or may not see within the subwatershed. We'll then get into sort of what the next steps are. What are we doing in phase 2 and 3? And then we do have a question period in addition to what is on the PTW, the website. And as Ian mentioned, this is being recorded, and I think you all probably got a little notification for that about 30 seconds ago. And Allison's running this, so she's I'm gonna say next slide a few times as we go through it. So the project team, Ian, do you want to introduce yourself, and then we'll introduce each of ourselves? So.
Yeah, sorry if I didn't do that. My name is Ian Boland, so I'm managing the project from the city's end. Right now, my city at the role is the interim manager of infrastructure management. Before that, I was the senior watershed project manager, so involved with obviously this project as well as our watershed plan, among other things. But
I'm Dave Maunder. I'm the project manager. I've been doing these types of studies, probably done about 40 or 50 of them throughout Ontario and a couple outside of Canada. And I sort of try and bring together the findings. Julie, you want to just say a few words about yourself?
Sure. Julie Scott, Aquifer Beach, terrestrial ecology. I've been kind of spearheading a lot of the natural heritage components of the project.
Oh, sorry, Graham.
Thanks, Dave. My name is Graham Eby. I'm the aquatic biologist with Aquifer Beach. So I'm working closely with Dave and Ian and Julie and focusing on the fish and the aquatics and the habitat within the stream there. And Allison, I guess that's you.
Thanks. I'm Allison Gingrich-Kergier with Aquifer Beach. I'm acting as the Water Resources Coordinator with the focus on stormwater. I'm also the one running the Zoom link tonight. So if you have any issues with Zoom, feel free to send me a chat in the message and I'll do my best to help out.
All right, do you want to hit the next slide? Ian?
Start us off with a land acknowledgement. We respectfully acknowledge that we are on the treaty and traditional territory of the Mississauga and Anishinaabe. We offer our gratitude to the First Peoples for their care for and teachings about our earth and our relations. May we honor those teachings.
Next slide, Allison. Yeah, so just the first thing we want to do is just present the study area. If you look on the left side, you'll see that the Harper Creek Subwatershed is located in the southwest part of Peterborough. And if you look on the right side, you'll see what you see and shown on the ortho image there is the proper boundary of Harper Creek Subwatershed. So it's bounded to the south by the CPR tracts, to the west by the municipal boundary. And we have lands down street and really drive sort of bisecting the subwatershed. You'll see in a moment that the provincially significant wetland is that green area you see toward the bottom right. And there are the blue things you see are what are called stormwater ponds that are built as part of construction. And what's shown in blue is just sort of the main tributaries of Harper Creek. And as per historic, there were probably more headwater tributaries that were probably piped as part of development, which you can see toward the upper end of the watershed. Next slide, please. So I mentioned the study purpose is, Harper Creek is it's an ecologically unique watershed. It has very sensitive features, and what we want to be careful of is there will be further development. We obviously have to look at things like climate change. And I mean, one of the things you'll note as we go through this, doing a lot of these things, the issues in different subwatersheds can change, not to bias it, but as Julie will point out, we're dealing with a provincially significant wetland located within an urban boundary, and we have brook trout. And as Graham will add, brook trout are very, very sensitive species of fish. They need clean water, they need cool water. They also need good habitat to live in. So there's kind of at least 2 jewels that we'd like to keep and make sure that if and when development does change or climate changes do occur, that we not only protect the subwatershed as it is now, but in the future. So what we will do is we'll evaluate the extent, what is the water quality like now? What might climate change do? What might changes in land use due to the natural heritage system? That's the trees, the flora and the fauna. Urban flooding, and you'll see in a moment, there could potentially be flooding within the residential areas and also adjacent to Harper Creek. And then the first phase is what we're presenting today, and that's to protect the natural hydrologic functions, protect the water quality in the creeks, the wetlands, and the rivers, make sure we can protect or restore a healthy aquatic ecosystem, and the same thing with the terrestrial ecosystem. And also, at the same token, support social, economic, and cultural activities that occur. I mean, we do have land development in this area. I mentioned there's 3 phases. The first phase, in simple terms, is define what you'll see in the presentation. And the second phase is to look at land use changes or climate change to see how that may impact it. And then what we really try and do is put together an integrated strategy that will not only protect what's there, but if there are issues, let's try and restore some of those issues. In other words, when we finish, we want to end off with at least what we have there now and hopefully better. Next slide, please, Allison. So the purpose of this PIC is just to introduce the study area, which we've already done, provide an overview of the subwatershed study purpose, which we've covered, and the process, which you'll see on the next slide. And then near the end is just provide an opportunity for the public to review the work, as well as point out what and when will be coming up in the future. And as Ian mentioned, we have a few questions for you at the end, and there's the opportunity to fill out information on the website. Next slide, please. So it looks like a long process, and although we've been at it for a while, the longest part of this process is just to basically go out. So what we've done is through a series of field studies or through a series of desktop analysis or computer modeling, we've tried to inventory the existing environmental conditions. And then really what we're trying to do is, what in the watershed is strong and what is weak and maybe needs to be improved. So that's really where we're at. The next phase, which has a lot of things to it, we'll look at it and say, okay, what would future land use changes do? So something's fine now, but we add urbanization, we typically reduce infiltration and we increase flows. And what might that do to flooding in the area or erosion, or what would it do to the integrity of the provincially significant wetland? Then we basically look at a bunch of strategies, subwatershed management strategies, and these are intended to improve conditions. So they could be restoring a stream, they could be providing buffers, they could be doing some physical work in the area, building stormwater ponds, or trying to install green infrastructure to try and recreate a natural environment. Once we come up with a preferred strategy near the end, then really what we do is we sit down with the municipality, the Conservation Authority, MNRF, Ministry of Natural Resources, and DFO as necessary, and put together a plan to make sure that it is implementable. We cost it, we look at a time frame, and we try and prioritize. So the bottom line is you want something at the end that everybody can agree will benefit the watershed. We can do it, we can find funding for it, and we know we can get the approvals for it. And then you always have long-term environmental monitoring just to make sure that what you said you were doing in 5 or 10 years is actually happening. Next slide, please. So I'm going to cover off each of the different technical resources we looked at. So the first thing is the groundwater resources. And this is So groundwater is everything at or below the surface. So what we really need to do in any study is, we all know when it rains that, the water runs off. And if you live in a residential area, you see it go into a catch basin, go underground. But in the bigger picture, when you look outside or parts of Harper Creek, a lot of water naturally falls, and it does one of 3 or 4 things. We get about, just to give you an idea, we get about 800 millimeters of precipitation a year. Actually, typically 500 to 600 millimeters of that is either taken up by trees or evapotranspirates. Of the remaining 300, depending on what kind of soils you have, majority of it, if it's a tight clay soil, will just run off, so to the stream or into a catch basin. If they're very permeable soils like a sand, it'll actually infiltrate into the ground. So what we had is we tried to get an idea of what is happening not only within this subwatershed, but adjacent subwatersheds. So if you look at the bottom map, basically, if you can envision a cross section through the middle of Harper Creek. So you've literally cut into the ground 100 meters deep. I think it shows 150 meters there. What we're seeing as you go into the ground, like the upper Newmarket Aquitard and the lower Newmarket Aquitard, they're less permeable soils. They basically hold water back that's underground, but the yellow features you see are what are called the aquifers. So that's where the water ultimately gets to. It travels very, very quickly through the yellow areas. And basically what water is doing is once it gets to that, it will actually regenerate itself or reproduce itself, potentially discharging to the streams. And if you want a brook trout fishery, you probably need at least 20% of your water coming from groundwater. So I mentioned before, we do have a brook trout. So what the groundwater section has shown us that we do have a very significant amount of water getting into the ground in different locations, but probably more importantly, coming back out either into the wetland or into the streams that support the brook trout. So again, this is a bit of a technical exercise as we put groundwater wells in. We gathered information from the Ministry of Environment, and we tried to get an idea of how water is getting, when it falls, where it's going, and what are the implications of that the hydrologic cycle is referred to. On the next slide, please. So on the left of this slide, really what we're showing there is, again, what we did through our technical assessment is we were able to identify where a small amount of water is getting into the ground. And while a small amount could be, obviously, if something's paved, virtually nothing's getting into the ground. To where you see the red and purple areas, there are areas where an awful lot of water is getting into the ground. The more water getting into the ground, the more potential we have for that water to come back out and support the streams. For example, usually the higher areas where you see the red and the purple is sandy soils, very shallow topography. So when the water falls, it quickly infiltrates into the sand, and it has the ability to migrate through the underground system and potentially back into the stream. On the right side, what we've tried to do is you can't just look at 1 year. For example, 2007 throughout Ontario was fairly typically dry year. So what you see in blue there is you see that the amount of precipitation that fell was less than in 2008, 2009, and the other years. And again, all we're trying to get on the bottom to sort of build our framework for this study from a groundwater perspective is look at the amount of rain that fell and whether it went into evapotranspiration, which again, just basically the water is going to stay at its source. Or as you see in blue, the interflow to other streams, this is what we're looking for, or runoff to streams or groundwater recharge. So again, we use this information in part when we try to look at the terrestrial ecology, the aquatic resources, the fisheries, or we look at flooding and we look at other elements. So this was sort of the core foundation, a lot of time and a lot of effort, but it did set us up for some of the other elements I'm going to talk about. Next slide, please. So the other thing is once we've looked at the groundwater, we kind of want to, stream morphology is just the shape and the form and the function of the stream. And in some studies we have a very significant amount of erosion. If you look at it practically, when you urbanize an area, you're probably reducing infiltration by about 50% and doubling runoff. The problem is that if it has more water coming into it, it has to adjust to that. So that stream will either become deeper or become wider, or a combination of the both. And the other thing is, it doesn't happen overnight. Typically, we found streams can take 2 to 5 decades just to adjust to urbanization. So again, in Harper Creek, we do have that urbanization in the upper end. But really what you'll see if you look at the bottom is the streams are generally susceptible to erosion. And what we've done there is we've just shown them, if you see the black marks, we've tried to categorize the streams because a clay channel stream will respond differently than a sandy channel stream. But in a general sense, the streams are referred to as end transition. So they're still adjusting to upstream development. But again, as I've noted, a majority of the stream reaches are healthy and could support a fishery, which is a good sign. So you'll see, if you want to flip to the next slide, please. We really didn't find much in the way of problematic issues. We've identified 5 issues, but they're relatively minor, and some of them are just human interventions. So if you look at the top, someone just decided to build, I don't know if that's a bell cable or a utility cable, but someone decided they just like to put a utility box adjacent to a stream. There are some fences and minor erosion, as you see on site 2. There's a couple little linear wires, or if you look at site 4, we have some form of pipe underneath the stream. And then, you're just seeing minor erosion at bends in the stream or at the upstream section of a water course. But we didn't really see much in the way of major erosion. And I think that's probably a nature of the types of streams we're dealing with, plus the fact that it's going through a wetland. So the stream has the ability to move. The last thing you want to do with the stream is try and tell it to go straight, because over time it's going to say, no, I'm going to change and meander back. And you do notice that where we do have the issues is where the stream has been more or less straightened along the CPR tracks. So again, from an erosion perspective, we're in fairly good condition for Harper Creek. Next slide. So for stormwater infrastructure and flooding, again, in layperson's terms, there's 2 types of flooding. You can have basement flooding because your storm sewer is undersized, or you can have flooding because you live adjacent to Harper Creek. So what we tried to do is we tried to assess the capacity of the existing systems, identify where flooding problems were, and this will provide insight for phases 2 and 3 of the study. So this isn't necessarily a field exercise, it's a modeling exercise. What we literally do is we run computer models and we try and figure out how much water's in each individual pipe within the sewer shed, and how much water's in Harper Creek, and how high that water builds up and where it might cause flooding. So some of the things we did find, the detailed findings are in there, but the Harper Road culvert, which you'll see in a moment, it's able to convey frequent flows, but the storms that we get every 100 years. I think Peterborough was hit in 2005 or 6, was it, Ian? Do you recall?
2004 was the big one that everybody references, and also in 2002 we had a good one as well.
Yeah, and I think that storm would be in and around a 100-year event.
Yeah,
and then we have
actually, but yeah.
Yeah, I thought it was a little higher. And then there's a long-term historical storm that's used called the Timmins storm, which is used sort of in the, I guess, the eastern part of Ontario as a historical storm that generally even exceeds the 100-year storm. But, if you can convey everything up to 100-year, the infrastructure is in reasonable shape. So next slide, please. So I'll just talk about this in general. So the storm sewer system, what you're seeing, and maybe Allison, you could just use your mouse to point to it. So what you're seeing on there is that's the storm sewer system that's literally underground on your roadway, underneath your roadway. And what we did is we looked at each pipe segment to see, and where you see green in the general sense means that So the city has a standard. What they like is if you get a storm that occurs every 5 years, they don't really want water on the road because it becomes an inconvenience. So they'd like all that water to go into the ground. For the 100-year storm, you see on the right, it's a combination of water in the storm sewer system, but also on the roadway. So when you have a 100-year storm, you probably will have water fill the roadway up to the curb and even higher. But that has to be an acceptable standard. Otherwise, you'd have to build very, very large storm sewers. So the gist is anywhere where you see green on the left, it means that the storm sewers were designed appropriately. And that's a simple way of putting it. They're supposed to convey the 5-year flow in the sewer, and they do it. Wherever you see the orange color up there, the sewers are actually sized a little smaller than they should be. So what are the implications? The implications can be twofold. If you have a foundation drain running around your house, and if that's connected to the storm sewer system, the problem is that if you get a big event and the storm sewer system can't handle it, the water doesn't actually go from your house to the storm sewer, it goes in the reverse direction, and it can actually cause basement flooding. But in a majority of these areas, the basements aren't directly connected. So we'll get into this more when we get to the phase 2 of the study, but we just need this information to get a gauge to see of the infrastructure that has historically been built. Is it adequate? And if not, where might it cause problems with respect to excess surface flooding, or where may it cause basement flooding? And I'm not sure we really need to add much, but we're just showing you sort of the length of pipes that maybe do not meet the criteria below. And that's basically taking the yellow, or the orange areas and adding them up. So again, the basement flooding will be addressed more in the second phase if there are issues. And sometimes it's putting in a bigger pipe if and when the city reconstructs a road. So it helps down the road for planning future infrastructure projects. Next slide, please. So what you're seeing in blue here is what's called the flood line. So again, this is, if you look at, maybe you could just show where the terminus point is. Yeah, just go up a bit and show where. So basically, Harper Creek flows into Byersville. So from that point upstream, you see in blue are areas that we would expect to flood for the 100-year storm. So it's fairly wide through the wetland. You can see it's kind of close to some of the industrial commercial development to the east of Harper Road. Yeah, and both the west and the east. So that's, we need to know that if there should be any land use changes or whatever, it's beneficial for the city to know where and where not they can allow development. And on the right,
Dave, can I just interject there for a second? I just wanted to highlight on this slide, sorry, that these are flood lines for the purpose of, our study and assessing flooding risk. They're not to replace any regulatory floodplains that the CA has available. It's not the intent. They're not done to the same level of detailed scrutiny. So
yeah,
I just wanted to make that clear. Sorry.
No, that's no problem. That's a good point. Yeah, again, this is more of a hands-on study for the municipality to use the product when they move forward. If you look at the bottom right, the Timmins storm is a little bit larger, but it's pretty hard to see the difference between the 100 and the Timmins. Further to what Ian just said, we always look at 2 regulatory storms being the 100 and the Timmins. You can have different criteria for the 100-year and for the Timmins. But again, this is just kind of a snapshot of where we may or may not have problems. And again, qualitatively in some of these studies we do, and obviously in other parts of Peterborough, the issues would be far more severe than what we're typically seeing here. So again, moving forward, we know that we have to focus maybe on other elements of the study. So I think the next couple of slides are for you, Julie.
Sure, thanks, Dave. So a large component of a subwatershed study is determining, or I guess more so in this case, confirming or updating natural heritage conditions, since there is previous mapping and information for this area. So that includes vegetation, wildlife species, habitat types, etc. To that end, our team used existing data from a wide variety of past documents, community science records, and local sources that were provided to us via the city, as well as the results of our own field investigations in order to just basically review what's there and evaluate its condition or sensitivity. Next slide, please. Surprising absolutely no one, the largest and most significant area for natural heritage was Harper Park. There are some small parks and patches of vegetation elsewhere, but mostly it's Harper Park and the sort of surrounding areas that we're going to talk about. There are extensive wetlands in that area, some with some interesting and unique vegetation community characteristics. There's lots of organic soils and some species that are more characteristic of fen type vegetation communities, which are definitely less common in the area. We also found a new population of crooked stem aster, which is a species at risk designated special concern. This species, which is pictured on the slide in bloom, was previously only known from southwestern Ontario in the Carolinian zone. So that's a fairly significant finding to have it this far north. There's other species at risk, as listed on the slide there, that were confirmed either in the park or in the surrounding area with supporting habitat functions, or were reported by background information. So either direct observation by us or from background information. The overall takeaway basically is just that Harper Park provides habitat for a wide variety of species, including some that are considered significant or at risk. Next slide, please. There we go. A fairly large component of our study was looking more closely at wetlands, specifically the provincially significant Harper Creek wetland complex. Older mapping of that feature was available via the provincial database. The wetland evaluation criteria were reviewed by others in a desktop exercise not too long ago, but the mapping was not updated at that time. So it was not necessarily reflective of what was on the ground right now. And we therefore felt that that was going to be one of our priorities for this study, to get that up to date. So the map shown on the slide here is a lot of data crammed onto one image. Hopefully it gets the necessary points across. Wetland mapping, per the usual procedure we follow, the first step is air photo interpretation and sort of a course level delineation from those air photos, followed by ground truthing to confirm boundaries and assess the different communities and structures that are present. So overall, what you're seeing here is a combination of both of those. We've shown in teal the areas where we were able to do field investigations to ground truth that initial mapping and collect some of our own data. The green are areas where we had more limited access or didn't access entirely, largely due to property permission limitations. So those lines in green could be subject to some refinement in future, although in our experience at least, you can usually get a pretty good idea of where wetlands are just from air photos. So we do feel like it will be more a matter of refinement and not a complete remapping in future. We've also shown here some wetland areas outside of that red line that forms the boundary of the Harper Creek Subwatershed. So that was our study area boundary. Some of these areas to the south were found to have a functional connection with the existing provincially significant wetland in our study area, either through being like a contiguous corridor of habitat, which was more the case in the lower left corner there, where you see that's just an entire continuous strip of very, very similar habitat with no barriers to wildlife movement or anything like that in there. Or you could also have a hydrologic connection with the downstream systems, which is the case on the areas to the right, which are directly connected along that drainage channel shown in blue. Our recommendation as part of the subwatershed study is going to be to complex all the areas shown into the provincially significant wetland. And these boundaries are what we're going to be submitting to the MNRF as part of our updated wetland evaluation system report for this area. So if and when that's approved, that will become the new wetland boundary, provincially significant wetland boundary, pending those future refinements I mentioned. Exact boundaries, like you would determine through on-site staking and survey, tend to be done during an EIS or site plan or later stage, not as part of something on the scale of a subwatershed study. And the usual caveats, ultimately this mapping has not been officially approved yet, but we have had several in-depth discussions with MNRF staff about the application of the protocol to our specific situation and on how complexing has been approached in similar situations in other areas. So we're pretty confident that our justification for complexing here will meet their standards. That's all I had to say here, Dave, if you want to take it back now.
Yep, I think just a couple more on the aquatics. From the aquatic perspective, I've worked with ecologists over the years, and they like to say that, the fisheries is a good environmental indicator of your overall health of the watershed in a lot of ways. I mean, you're looking at physical attributes, you're looking at chemical attributes, and you're looking at biological attributes. And as I mentioned at the onset, the fact that we have brook trout in an urban area is a very nice thing to see. It's also not particularly common because unfortunately, usually urbanization does cause a detriment to the fisheries. We undertook some field work here. We used information from MNRF, but I think, the findings are important. There's a large population of brook trout, which is, as mentioned, a cold water indicator species. There's spawning and rearing habitat best along Rye Street, and you'll see that photo of that in a minute. There's also refuge and in-stream habitat is best within the park, and the spawning studies show potential spawning beds along the main branch. So that's a good start, and that's something we definitely want to preserve. So the next slide just show a couple of the figures. So we have Rye Street to the top right. And again, Graham will add to this. I'm not an ecologist or a biologist, and he will, but it's pretty rare to see brook trout in a stream that's basically been straightened that wants to not be that manner, but they are there. And it's I think probably in part because of the proximity to the cold water inputs and critical spawning habitat. We have done work on other parts of the stream, and I just highlight on some of these here. The West Branch also has high brook trout productivity. In the main branch, we have kind of maybe a balance between Mother Nature, where we have beaver dams, and whether those beaver dams should be part of the overall natural system or should something be done with them. But again, we will look into, when we get to the second and third phases, of making sure we preserve what's there. And again, I mentioned very upfront, we spent a lot of time on the groundwater, and we need to understand that groundwater process if we're going to preserve, what we have there now, and indeed try to improve it in the future. And again, the problem is with potential change in climate change or with changes in land uses that you may adversely impact those. So, Graham, I don't know if you wanted to add a couple of more things to the aquatic resources.
Dave, I think you did a pretty good job, despite you acknowledging that you're not an ecologist, but I think you did a pretty thorough job. I just wanted to point out that the entire subwatershed was walked by myself, all the way from the confluence with Byersville Creek, all the way up through that Rye Street branch, and along the main branch into the West Branch, and then all the way through the parks and up to the headwater areas where they would have existed at one point. But like you said, there's a variety of habitat throughout this system, with a lot of the really valuable habitat found within Harper Park. Like Julie mentioned, the provincially significant wetlands and the groundwater contributions really play an integral role into maintaining that habitat. And despite that habitat being a little bit broken along Rye Street, we still see some of the most productive brook trout along this branch because of its proximity to that groundwater contribution. So I'd be happy to answer any more specific questions as we get into that portion of the presentation, but you can take it away from there, Dave.
Okay, thanks. So there's just one more slide, then we'll get to the next steps. So the surface water quality, we kind of show those two jars there. So the jar on the right would just be a typical, what water would typically look like from either from groundwater discharge or from a forested area, whatever, whereas the jar on the left is from a representative residential storm sewer. And so typically we need to make sure that water quality, as I mentioned, physical, biological, and chemical, water quality can be a limiting factor in a stream system. So what we are doing is we're taking samples and looking at other information to see if water quality may be a limitation, and if so, what do you do with it? A lot of municipalities now are trying to offset the impacts of urbanization through implementing green infrastructure down the road, trying to recreate naturally what's coming from a subdivision as opposed to just, sort of pouring the water quickly into a pipe. The historical work has found exceedances in conductivity, metals, total phosphorus, which is totally standard. I mean, typically the concentrations coming from an urban area, typically, for nutrients are going to be 10 times the provincial water quality objective, for metals 10 times. Solids doesn't really have a standard, but if the water quality is an issue and we find it to be an issue, we'll need to look at things, but we're still gathering some of those samples. So we'll be presenting that in the next PIC. So the next slide, please. So the next steps, and again, I'll just mention them briefly. So we'll take your feedback and everybody else's feedback that we get from the agencies, and then we'll put together a final phase 1 report. And then phase 2, as I mentioned, is basically we identify weaknesses, we identify things that are strengths, but even if it's a strength, we want to make sure that climate change or changes in land use don't cause detriment to that. So what we'll do is we'll go through an assessment to see what conditions are now, how they change due to climate change or future development. And then, we propose protection, mitigation, and management. It can be a complex manner of strategies from reforestation or different works in the urban areas to stream protection works, a variety of things. And we find out which ones are effective and which ones aren't. And then really for the phase 3 of this, which is after we present this at the second open house, is just, as I mentioned, how do you implement it? Where do you get the funding? Who's responsible for it? What's the priority to do, that kind of thing. So that'll be done over approximately the next 6 months. Next slide, please. I think the next slide is just the comments. So Ian, I don't know if you want to add a little bit, but I'd like to see if there are any questions, and we have put together a few questions here if there are none.
Yeah, that was a lot of information, Dave, and I appreciate that. Hopefully everyone found that useful. It is a lot of information. It's a lot of technical information. Maybe it's raised more questions than answers for you. I don't know. But we're here to answer any questions you might have or any comments or concerns you might have. And again, I mentioned it earlier on. If you're not comfortable, raising a question here, by all means, you can reach out to me, or you can use the Connect BTBO site as well. So I guess our first, we've tried to trigger a few questions here. What environmental issues or concerns have you noted within Harper Park Subwatershed? So I think as Dave mentioned, we've walked quite a bit of the site and we've highlighted a few issues, but there might be some smaller things that you've noticed. So we're still looking to gather that kind of information. So I guess we can just open the floor up. You can raise your hand or just speak up.
While folks are thinking, I've received 2 questions or comments during the presentation. So the first one was about data collection and whether or not that includes data loggers for temperature, volume, dissolved oxygen, or any other metrics.
Dave, do you want to answer that?
Yeah, so we are doing that as part of the water quality assessment. So that is the ongoing part of it now. So we put in small devices that do a majority of things. I have to look back and see exactly what we are gathering in the way of information. But we can respond to the details of that, Allison, in our response back.
Sounds good. And the second one was just a comment that the brook trout were DNA tested and were deemed to be genetically distinct.
That is true, and that is, yes, we're aware of that fact, and it makes them one of the most unique species in this area, certainly. So, well, maybe even in all of southern Ontario for that actual reason. So Let's go to, I don't know who this is. It just says Duncan's iPad. So I guess it's Duncan. Go ahead.
Thank you, Ian, and the other members of the committee for providing this opportunity to contribute. My full name is Duncan Armstrong. I'm a semi-retired M&R employee. I live on Fort High Drive, which is bounded by Spilsbury and Brayley at the south end. While I was with the Ministry of Natural Resources up until the early 2000s, I was working on behalf and managing the stewardship program in Peterborough County. So we worked a bit with Trout Unlimited, and it was Jack Imhoff at the time, who was one of the leaders in cold water stream rehab and protocols for first, second, third order trout streams, headwater streams particularly. And he's the one that put me on to the genetic uniqueness of the brook trout. My particular point that I'd like to make is back then we had tried to engage the City of Peterborough to plant red osier dogwood along Rye Street, which had used to be where Kawartha Lakes Brewery is. And I think it's called Haven Brewery now, right at that 90-degree corner where it goes from west, east to south, north. And when we had sets of data loggers in there in partnership with, I think it was Orca that actually has the data. So if you're looking for some baselines, that would have been back, I think, 96, 97. But my one thought is that's a particularly important part of this watershed where we've noted that during low flow, high summer temps that all the brook trout were retreating into that area. And so we wanted to plant red osier dogwood or something there. So my one recommendation is that there's a bit of knowledge transfer, I think, that has to occur with some of the owners of those commercial industrial buildings, because back then we could not convince them as to the merit of planting some low level vegetation to shade the water, to keep water temps down, to reduce erosion impacts further downstream. And so anyways, that's just the one comment I wanted to make. We had collaborated and done a lot of tree planting with Crestwood and some other schools. There's certainly pools of labor available to do that type of project. And I know that in this neighborhood, there are a large number of M&R employees who would love to come out with their kids to do a planting. If at some point down the road, that type of project is one of the outcomes of this exercise. I don't want to presume it is, but my most important thought was just to say that there are data logger records, whether they're still relevant to the study and who currently has that data, I'm not sure, but it does exist. There was at least half a dozen in there for 6 months back in the late 90s.
That's great. Thank you for that bit of information. That sounds like around the same time that the original subwatershed study was prepared. So it could be some data that was used as part of that. And I think your mention of, improvements to the Rye Street area, that's certainly something we'll be looking at and looking to make some recommendations and hopefully create some different stewardship opportunities, partnerships, things like that to help see these things through. That is certainly one of the goals, in phase 3 of the implementation plan of this. So that insight there. It's always interesting to hear some of the history within this area. There's definitely a lot of it and a lot of information out there. So that's great. Let's go
Ian,
to.
Do you mind if I jump ahead of sorry, I meant Ian Attridge, not you. Not you.
Go ahead, Dylan. Go ahead.
Yeah, no, I was just gonna say, Duncan, you and I should touch base. I've actually got a really good contact with the Crookshanks who own the property at the corner of Rye Street there, and we are talking about potentially doing some work with them in the coming years. So if you're interested, just shoot me your contact information over DM. We should talk about that. So yeah, because hoping to do some good work like that in the coming years. So I wanted to say also, just kind of expanding on that, like I noticed there was a bit of a note on the topic of providing some input into what there might be as far as potential stewardship interventions there might be along Harper Creek there. And so this one, I guess it might be a little bit more for Ian, just because it's probably a little bit more of a City of Peterborough matter, but I was curious about kind of how you might propose like tackling if there might be some sort of a like formal strategy for and timeline for implementing some of the potential stewardship opportunities. I just ask because I know there are a couple of projects that have been proposed by the city over the year and kind of languished and never just really gotten off the ground. And so I was wondering if there was going to be some recommendations around how these projects might get funded, staffed, or anything like that in that nature. So
yeah, I think at this point in time where we are with the study, I wouldn't be able to give that the answer it deserves right now, because that's still something we're going to look at through future phases, phase 2, phase 3. But it is certainly something we want to come out of this study is, formalize those stewardship opportunities, identify those areas that need to be addressed. Maybe they're smaller projects that can be tackled through different groups. They don't have to be big capital projects, and identify, opportunities for funding those projects. That is certainly a goal at the end of this project, to have that information and present that kind of information to council and to the community as well. So I don't have a timeline on that right now, but it is certainly something we're looking at. So right now, if there's existing opportunities that we're not aware of, we'll take that information and work with yourselves and others on, formulating exactly what that could look like moving forward. Is it a single group? Is just engaging multiple existing groups? That's the kind of information and I guess like discussion and feedback that we're looking for right now. So
great. Okay, thank you.
Yeah, thank you. I guess you can go ahead now, Ian Attridge.
Thanks, Ian. And thanks for hosting this information center. It's really helpful to get caught up on where the study's at. I'd encourage you to post the slides as well as the video, because sometimes it takes a while to get ourselves through the video, and the slides are a good distillation. I had a couple questions, and they may speak to the terms of reference for the study, but also some of the results that you're contemplating, that you're achieved or are contemplating. And those relate to a couple of things, looking at the information that was sent out to us. The first is whether you're looking at significant valley lands, significant woodlands, and I think, Dave, you mentioned that you are looking at significant wildlife habitat. I haven't, I guess you've talked a bit about it in terms of fish habitat, et cetera, but it would be helpful to get a clearer sense of some of your results on that front. And secondly is the cultural values of the site. Again, in the package that was circulated to us, it indicated that you're also identifying cultural values, and I'm wondering what some of your findings, or when you may have some of those findings, and how they will interact with the ecological findings that you shared tonight. Thanks.
Those are both good questions, and Dave, or maybe Julie, can I get you to comment on that, on the valley lands and other things?
Well, I can speak to the ecological components. Definitely significant woodland, significant wildlife habitat, all of the natural heritage components are something that we go through. Like we go through that checklist according to the whatever policies or criteria are applicable to that category, and identify those as part of the study. It didn't get touched on perhaps in detail in the presentation, just because we're blitzing through this at light speed. But yes, those do get considered. Valley lands, Dave, maybe you could address how that was.
Yeah, I think just to address the in stuff, I mean, the way I look at significant valley lands, woodlands, et cetera, you kind of look at the natural heritage stuff, erosion setbacks, meander bends, floodplain delineations. And, I don't know that we had too much in the way of like erosion, valley, like steep slopes and stuff like that. But the report does kind of blend all that stuff together, Ian. We were just trying to give sort of a highlight.
Yeah, fair enough. I realize you can only present some of the highlights and a limited selection tonight. But perhaps you can also speak to the cultural values, and also speaking how those may also identify species of cultural value to First Nations, and how it may affect not only those First Nations, but our responsibilities to be in right relationship with First Nations. So, yeah.
No, absolutely. And I'm glad you brought that up, because I don't think it was highlighted in our presentation. That is a significant component of this exercise. Part of Dave's project team is working with Cambium Indigenous Professional Services as a liaison, between ourselves and with our First Nations communities. So we have initiated a couple of meetings with them and started to gather some background information related to cultural heritage and looking at various significant species of importance, and we do want to identify where those exist, looking at what's important, and again, bridging that gap between, that cultural aspect with, our technical aspect here. So yes, that is certainly something we're working on. And it's a major component of this study. We don't have all the results of that right now to share with you, but we will in the future.
Great.
Yeah, just maybe add to that, we are actually trying to coordinate a couple of site walks through the PSW and stuff like that with First Nations. I think we had one issue because of timing or COVID. I don't recall what, but we are coordinating that. It's quite interesting to hear their perspective on some of the stuff that we might look at a bit differently.
Your hand.
I've had a second or another question come through, and the question is, how will the findings of the study affect lands outside of the city of Peterborough? And will any stormwater management plans be applicable in those areas?
As of right, sorry, was the question lands outside of the city of Peterborough?
That's correct, yes.
So this study and any, policies that we develop would be specific for the city of Peterborough, obviously. The data is going to be available to everyone. We're going to work closely with the Conservation Authority as well. Something of note, I don't know if you touched on it, Dave, when we look at the groundwater resources and where those groundwater features are coming from, they are not bound by the subwatershed boundary. Subwatershed boundary is really just looking at surface water. So you may have a significant, groundwater input that's outside of the subwatershed boundary that is key to feeding Harper Creek. But again, areas outside of the city of Peterborough is ultimately, out of our control. But again, the study is going to be available to others, to the township or the Conservation Authority to use basically as they wish. So yeah, long story short, I guess the answer is, nothing we have in here is going to be necessarily used outside of the city of Peterborough for this specific study. But it would be important to look at that and sort of look at advancing those discussions further. So. Doesn't look like, do we have any other questions or comments, concerns? I know it's, it's a lot of information, a lot to take in. There's still a lot of work to do. And I know a lot of people like to, get into the nitty gritty, the final plan, the recommendations, things like that is usually where we see the most comments and concerns come up. But I think it's still important to hear everyone's thoughts now so we can inform that, but understand, it's getting close to dinner time now. So everybody's probably getting hungry. So I would encourage you, if you have any comments, to submit those through Connect BTBO, or you can reach out directly to myself as well. So.
Ian, I think Lynn Smith has her hand up there.
Okay, so I can't see everyone at once. I have to keep clicking through. Go ahead, Lynn.
Hi, I just had one question about the Rye Street Creek is is so important for brook trout, but I don't see too much, or I didn't hear too much conversation about the headwaters, the north tributary, and how hydrologically that works in the system, and what I don't know, what you found there, and how that will work when they start to restore or some of the area for the trout along Rye Creek. I just wondered whether it had a fair amount of study done as well. Harper Park and those creeks have. I just was curious about that tributary.
Yeah, Dave, do you want to comment on that?
I was just wondering if Graham might be better. He did the field work, yeah.
Sure. Yeah. Thanks for the question, Lynn. As far as the Rye Street branch goes, if you actually walk upstream from where it runs adjacent to Rye Street and at that 90-degree corner, you can follow it into Harper Park, where you actually find it bubbling out of the groundwater contribution. So as far as upstream studies go for the Rye Street branch particularly, a lot of that will come from the groundwater analyses and the hydrologic studies. As far as the main street or the main branch of Harper Creek within Harper Park, a lot of the headwaters are confined to currently developed areas. So some of the west branch falls onto private property where we couldn't necessarily access, but and similarly, the main branch, which flows north into the heart of Peterborough, is now buried under parks and under residential areas, which is contributed by stormwater management. But we'll actually find within a lot of these streams, including the main branch and the west branch, as well as Rye Street, it's largely contributed by groundwater, which is present from that provincially significant wetlands and that those aquifers that Dave mentioned at the start. So as far as in situ investigations go, a lot of them is actually confined to within Harper Park, because that's where we see a lot of the major contributing features that contribute to that valuable brook trout habitat. I hope that answers your question, but there will be more information that comes from some of those background investigations.
Yeah, and I'll just add to that too. There is significant work done previously as part of an environmental assessment in the area, looking at groundwater inputs in that creek, as well as a lot of background on the fisheries aspect there as well. So there's certainly for any of these tributaries, we didn't find a shortage of information. That is certainly true. There's quite a bit of study out there. There's quite a bit of information, which is great.
Okay, thank you.
I've received another comment from a resident who lives on Cahill Drive adjacent to the swim pond. This person was an original buyer and received a notification about the sensitivity of the stormwater facility and not to use too much salt or fertilizer on the property, but there have been significant property changeovers, and many don't know. So the suggestion is for another notification to be sent out to residents in the area.
Yeah, that is certainly a good idea, and I think something we should look at, and possibly even something we'll look at is just that overall educational component as part of our implementation plan, just to make everyone aware of the sensitivity in the area, things like that. So that's a good comment. That's a good item to bring up, because it is important. People move in and move out and may not be aware of what goes on in this park and in this creek. So that's great. Thank you. So I don't know if nobody else has anything to add. I certainly appreciate everyone's time today. I know we've all been hard at work shoveling our driveways lately, so probably want to have a bit of a break now and eat some dinner. Again, I mentioned it before. Yeah, just reach out to me or through Connect PTBO if you have any comments and concerns. Subscribe to that page because we will, I think whoever mentioned it, was it Ian? We will be posting the PDFs of the slide today up there right away. The video, yes, it may take a little while to upload, so, but we'll get the PDFs as soon as we've made them AODA compliant. We'll get them up on the web page. Hope to have a draft report for phase 1 up there as well soon for everyone to take a look at and review, as well as any other, events that come up. So subscribe to that page so you can be aware of when that's happening. And if you want to reach out to me directly for any sort of comments or concerns, by all means, please do that. So I guess, thank you very much. And I think if there's nothing else, we can let everyone go.
Thank you.
Thanks, Ian.
Yeah, thank you very much.